Hello, Internet, and thank you very much for tuning into Cloud Native Islamabad YouTube channel. It's been a while. We did some webinar on this YouTube channel as well. I think remember in the March we did a presentation on Score open source project by Humanitech. But today I'm speaking with my new guest from Microsoft, and they will introducing us some of the new capabilities. They're actually trying to experiment with a new tool called Inspector Gadget. So all you know that the good system observability facilitate faster and easier problem investigation and diagnosis, and it helps developers pinpoint issues through specific data points and action leading up to those points. So this webinar will introduce Inspector Gadget, a CNCF sandbox project that is a tool and framework for data collection and system inspection on Kubernetes cluster and Linux host using eBPF. So without any further delay, I go straight to my guest, Qasim Sarfraz. Over to you, Qasim. Can you introduce yourself?
Hi, I'm Kasim. I currently work as a software engineer at Microsoft. I'm one of the maintainers for Inspector Gadget as well. And other than that, I also like to contribute to different open source projects. Yeah, and it's
Glad to
really
see
nice to be
you.
here. Yeah,
Awesome.
same
Glad
here.
to see you. And now, Maya. Over to you now. Can you introduce yourself?
Sure. Hi, everyone. My name is Maya Singh. I am a product manager at Microsoft working on the Inspector Gadget project, and I'm really excited to be here to talk with you all today.
Awesome, great. So the stage is yours now. So I won't be interrupting you much. But as soon as I saw some chat or some questionnaire in the chat, I will just definitely interrupt you as well. So Qasim, can you share your screen so we can
Yeah,
start the agenda?
okay, perfect. Can you
Awesome. I
see?
hope. Yes, I can see it. And people, if you don't see the screen, do let me know in the chat. But I can see it perfectly fine. So this means time for us start learning Inspector Gadget. Over to you, and I will be off the line.
Okay, perfect. Thank you so much. Uh, Hello, everyone. Today we'll be talking about optimizing developer experience using Inspector Gadget. The idea of this talk is to kind of showcase how to use Inspector Gadget to make most of out of your Kubernetes-based platform. Before we start, uh, I'm Kasim. I work as a software engineer at Microsoft, and I'll hand it over to Maya to kind of introduce the project and tell them a bit more about it.
Definitely. Yeah. Hi, everyone. Like I mentioned, my name is Maya. I'm a product manager at Microsoft working on the Inspector Gadget project, and I'll be giving you a little bit of a rundown on our agenda and the project a little bit. So here's our agenda for today. We're going to be reviewing, we're not going to bury the lead for you all. We're really going to start off and tell you what is Inspector Gadget? What is this awesome CNCF sandbox project that we're here to introduce to you all? We'll give you a little bit of insight into how Inspector Gadget works. And hopefully you'll find this next part really exciting, the common use cases. So how you can actually use Inspector Gadget to implement in your platform engineering strategies as it relates to troubleshooting and observability. We'll talk a little bit about the control mechanisms for gadgets so that you can use the gadgets in a way that makes sense for you and feel secure in using Inspector Gadget. And then people love hearing what's on the roadmap and what's next, so we'll cover that at the end. Awesome. So yeah, what is Inspector Gadget? Inspector Gadget is a set of tools and a framework for data collection and systems inspection on Kubernetes clusters and Linux hosts using eBPF. So this project is a pretty versatile project, and hopefully throughout the presentation you'll see that it's meant to really be a framework that you can change and manipulate to fit your specific platform engineering needs. And we'll get into it a little bit later, but we also provide some gadgets off the shelf, so you can get started with this tool quite easily. So yeah, that's what Inspektor Gadget is from a definition perspective. I want to review some what I kind of call like key concepts as it relates to Inspektor Gadget. I think it's important to sort of understand a little bit about what makes Inspektor Gadget so special by sort of understanding these key components. So with Inspektor Gadget, the first thing that comes to mind is, of course, the gadgets, right? We talk about Inspektor Gadget being a tool and framework for systems inspection. So the actual thing that is doing the inspecting are these gadgets, and the gadgets are OCI images that include eBPF programs, which are what is actually doing the data collection and inspection at the Linux kernel level. So these are, we'll get into it a little bit later, but these are sort of the core, they kind of hold the core functionality of Inspektor Gadget as it relates to getting very valuable data from the Linux kernel. So that's sort of one key component of Inspektor Gadget. The next one I want to talk about, and the one that you all who are part of this community are probably really interested in, is in the fact that it is Kubernetes and container aware. So when we think about eBPF or even Linux kernel data more generally, it's very granular, right? And when we collect data from the kernel, it doesn't necessarily understand the context of containers or Kubernetes. So what we do, and sort of the magic with Inspektor Gadget, is we are automatically mapping these low-level granular kernel level data to higher level Kubernetes and container resources. So as someone who's working in Kubernetes, working with containers, you don't need to necessarily be an expert in kernel level data to understand what's going on with your system. We kind of take care, the Inspektor Gadget project kind of takes care of what we call this like enrichment of the data for you, so that you can understand this kernel level data in the context of what matters to you, which is probably Kubernetes and containers, if that's the infrastructure you're using. And then finally, the last sort of piece I wanted to highlight of Inspektor Gadget is the fact that it is a framework. So I alluded to this earlier, but we really wanted to create this modular framework in which you have everything you need to collect, filter, enrich, and format this valuable systems level data in a way that makes sense for you. And you'll see later on when we get into some of the use cases that the framework is quite modular, and really it's a tool, and it's a way for you to really use Inspektor Gadget in a way that makes the most sense for you. So yes, now I'll hand it to Kasim to give a quick demo now that we've talked a little bit about what it is.
Okay, great. Thanks, Maya. I think, so now that we have a pretty good introduction about the project itself, let's try to kind of showcase what it actually feels like to use the project. So the first thing to kind of use the project is to install it. And for that, we have a kubectl crew plugin based installation, which means that you can use kubectl crew install gadget, and that will give you access to kubectl gadget command. And that's kind of what you use to interact with this tool. Once we have installed that, it shows that so it has the client side and the server side. With the crew plugin, you actually get the client side, and we see that it installed the latest stable release, which is version 0.32.0, and nothing is installed on the server side. So the next step would be to really install something in the Kubernetes. And to do that, we can use Helm. So we have our official Helm charts, so you can also integrate them in your GitOps or any way you want to install it. But for the purpose of this demo, we also have our own tailored command for installing the project. In this case, I'll just quickly run that. And this will take care of installing all the Kubernetes manifest with the right configuration in a AKS cluster I'm running. So once the command is done running, we have a Inspect Gadget Kubernetes daemon set installed on all the nodes. And that's where we can now start to showcase what the idea of Gadget is. So like Maya mentioned, a gadget is kind of one of the core idea of Inspector Gadget. And it allows you to do a use case specific debugging or troubleshooting. So in this case, you can see I run a command with kubectl gadget run. It's pretty similar to how you, for example, run a container, but you give it a name of the gadget you're interested in. So in this case, I'm interested in snapshot process. This specific gadget allows you to see processes running in a container. So think of it as PS, but container and Kubernetes aware. So once I run this command, I see all the processes running in this specific pod. One of the cool things I really like is that with the advent of distroless images, where you cannot really access the shell and run different commands, you can use tools like and the gadgets like snapshot process to really peek into what's really happening in a specific pod. So the next gadget I want to talk about is a bit of different use cases, and that actually traces the DNS request in a cluster. Again, you can see here that you can filter by namespace. So if you only care about a specific workload, you can focus on that. And you can also use the labels. In this case, I'm using the labels for core DNS pods. So then it'll make sure that it traces the DNS requests that are happening around core DNS. So that's already really powerful way to introspect your workloads. And as soon as I run the gadget, I'm able to see what's really happening in my core DNS. You can see some requests are failing, some are doing okay, and thereon you can already kind of identify different issues with your cluster and workloads.
So,
It's
Kasim,
time to,
yes,
yeah.
just a one question on my side on this front. So, let's say if there is a new need to add a gadget,
Yes.
if inside the Inspector Gadget, so what should be the next step for somebody to actually start adding their customizable gadget in the Inspector project?
Yeah, I think it's a great question. I think that's what we've been trying to achieve with this framework Maya mentioned, and so we have pretty good documentation around that. And I think we can defer this question because in the slides we will point you to the like this hello world example where you can, as someone who's really new to the project, can play with it and try to understand more.
Okay, thank you, Kasim. Go ahead.
Yeah, okay. Then I hand it over to Maya to kind of deep dive into the project again.
Sure, thanks. So now that you all sort of have like a high level overview of what Inspector Gadget is, we kind of gave that introduction and you saw how it works with the hands-on demo that Kasim showed. I think we want to give you a little bit of a look under the hood in terms of how does this work? What is actually happening in the background to make the data that you saw on the screen possible. So wanted to give you a little bit of an overview and we'll keep it at a high level, but if you're interested in depth in any of these topics, we have some other, talks on our README and stuff that you can definitely go to learn more. But just a pretty high level overview of how this works. We have these gadgets that are including eBPF programs. And that's what the little B is. For those that don't know, the little B icon is the sort of the mascot for the eBPF project. And for the audience's context, eBPF programs are a way for us to work within the Linux kernel in a very safe and performant manner. So, when we're thinking about the kernel, we want to make sure we're doing so in a sort of responsible way and making sure it's not putting too much strain on the system. So the project, the Inspektor Gadget project, really relies on this eBPF technology to gather this kernel level data from the system. And what we do is we take that kernel level data, and in the kernel itself, we do some filtering and enrichment of the data. So that happens in the kernel in a very safe and performant manner as well. And what happens is this data that has been now filtered and enriched to be very relevant to the audience and the context. What happens is that data gets sent to an eBPF map, and this eBPF map is where the user space is able to access the data. So when we're in the user space, we do some additional advanced filtering, the processing of the data, additional user space processing of the data can occur, and you can then export the data, share it, distribute it, and use Inspektor Gadget in many different modes, which we'll talk about a little bit later. But all of these bullets that are on the right-hand side around filtering, processing, exporting, sharing, all of this stuff, these are, again, like when we talk about the framework, these are the pieces that are super customizable. If you want to export it to Prometheus, you can do that. If you want to just export the data via JSON file because you want to, someone came up to us as like, we want the data in a machine readable form, you can do that as well. So that's kind of where we want this to work for you all and work for the community, which is why we have the framework in such a modular way. So that's just a little high-level overview of how it works. We can go to the next slide, and I'll talk a little bit of a gadget and this about the anatomy of a gadget. And this is kind of getting into the question of like, hey, maybe I'm interested as a community member to build my own gadget. When we look at a gadget and sort of deconstruct it, we want to think about these different parts of what sort of is inside a gadget. The gadgets themselves, as we mentioned earlier, are OCI images. So that's kind of, again, part of this modular framework, because the images can live in a container registry, and we can share and distribute these images in whatever way we think fits our use cases, which I think is a really cool way to like build the community, build off of gadgets, share them, distribute them. And the fact that the gadgets are in this OCI image form makes that quite easy. So that is like one of the fundamental things about the project that we wanted, is to like make it easy to share and distribute gadgets. And the fact that it's in an OCI, the gadgets are OCI images, is like kind of a key component of that community aspect of the project. So yeah, okay, so we have this OCI image. What's in it then? What exactly is this anatomy of a gadget? We have a metadata file that includes information about the capabilities of the gadget, the output, formatting, build information. We also have the eBPF program, and that's kind of like what we were talking about. The eBPF programs are what allow us to gather the kernel level data in a very safe and performant way. So the gadgets would include, of course, this eBPF program. And also there's the option for a user space module, a WASM file for you to do some post-processing of that eBPF data. So when we think about the chart with the line, dashed line down the middle, there is some processing of the data that we might want to do in the user space. And we can use a WASM module for that, which is, I think, again, trying to emphasize the modularity and the customizing of the framework to what works for you. And yeah, we're looking to include documentation, source code, maybe logos, all of that good stuff in the future as well. Cool. So we wanted to talk a little bit about where to find gadgets. So you could make your own gadget if you wanted to, and we'd love that. But if you want to just get started with the project and maybe use the DNS gadget that Kasim demoed, you could definitely go to Artifact Hub, and you can see that we have Inspektor Gadgets as a type of artifact on here, and you can see sort of what we're calling like official gadgets from the project, and you can use the filters on the left-hand side to sort of filter by the CNCF official project artifacts from the project. And eventually, we'll hopefully have a bunch of community contributed gadgets there as well. We already have like one or two in there, but this is sort of a great project. The Artifact Hub project is such a cool way for us to make sure the gadgets are easily accessed and searchable almost, which is kind of cool. And I'll hand it to Kasim to talk a little bit about the modes of use.
Okay, thank you. I think it's really like one of the things about like Inspektor Gadget is it being able to run in different modes. So this is kind of a decision tree. So if where you want to run Inspektor Gadget, but you're not sure how to run it, but if you want to run it on Kubernetes, we have a couple of ways. One is like the daemon set way, which I just showcased in the demo. And in that case, you install the Kubernetes daemon set, and then you interact with it using kubectl gadget. But if you really want to quickly try it out, you can just use kubectl debug node. And I really like it because if you know that you want to debug a specific node or observe a specific pod, you can just use kubectl debug. And it has all the information in our quick start guide how to kind of try it out for a specific node. Again, if you want to inspect our Linux system, we again have two ways. One, if you want to quickly try it out, like you can just install the IG CLI and then start to debug the host you are on. Otherwise, if you want to run gadgets for a long time, you can use IG daemon, and then we have a different client called gadgetctl. So this kind of showcases that all the different type of workloads Inspektor Gadget covers. So now that we have talked about the project in general, like what sort of components are there, what sort of capabilities are there, we want to connect the dots and talk a bit what Inspektor Gadget is for platform engineering. So if you want to offer observability as a self-service, which means that you might want to offer Inspektor Gadget or observability to your developers, and the framework side of Inspektor Gadget really shines there, because it's not like we are deciding what instrumentation data is collected. You can write your own gadgets, or the users can write their own gadgets to decide what instrumentation data to collect. So that's kind of the flexibility nature of the project that allows it to be part of Kubernetes-based platforms, where if you have a very specific or niche use case, you can write your own gadget and target it. Otherwise, like we showed for the Artifact Hub, we have a list of official gadgets which cover most of the troubleshooting or observability scenarios, and then you can already use them. The second thing which makes it kind of really suitable is the high performance bit, because it uses eBPF. So it ensures that like we were filtering most of the events, if I target a specific pod or a container, the filtering is happening in the kernel using this eBPF program. So that kind of ensures that you have a high performance. And again, you have this comprehensive end-to-end visibility. So especially in Kubernetes, where you can have your stateful applications running somewhere else, like for example, databases that not really in Kubernetes, but they're running outside on maybe some VMs, and there you can, for example, use IG or because of this different supported modes, you can still cover different sort of workloads. So that's kind of the various requirements that we check to be a tool or a framework that allows you to do observability for a specific platform.
Qasim, I have just one question from my side as well. In the cloud, specifically, let's say in AKS, EKS, GK, where you don't have observability into the control plane, you just deal with the node, only the worker node as well. And sometimes you need to check how the control plane is monitoring all of the pods underneath, how the scheduling these kind of stuff as well. So in the cloud, can you share some of the use cases while people are in the cloud? What are some of the challenges you see often people are facing, and how Inspector Gadget can be a go-to tool for them for the troubleshooting needs?
Yeah, I think it's a great question. I think what happens is that because of this, like you said, because of the control plane and the node separation, sometimes you have this issue that someone writes a Kubernetes operator and they're not really written it to the best, so it's making too much query to the API server, right? And in this talk, I'll showcase a tool called Top TCP, which allows you to see which of the specific pod across your entire cluster is making most of, or generating most of the network traffic. So these kind of are the gadgets which allow you to see if your pods in your specific cluster, like the customer cluster, are putting heavy load on the API server. So that's kind of one of the ways to kind of debug these problems. And also like I talked about a bit in the start, like this DNS gadget, because of its interaction with core DNS, and that's also that actually runs with the customer node, but it's kind of a control plane component, so you can also really debug your DNS problems up to the component you like. And you can check out our documentation. I think we have a pretty detailed guide in terms of how it helps to identify the exact components.
Awesome. And also, I think one more question on the same front as well. Sometimes the network policies are actually messing up all the time. It happened to me for a very long time as well. Sometimes network policy, they should be in place, they hasn't. And sometimes where the network policy no need to be in there, but they are there and blocking you stuff out and preventing you to actually deploy something stuff as well. What are some of the visibility we can actually achieve with this gadget approach for the network policy needs?
Yeah, I think one of the cool things about this approach is that you can really inspect the network traffic and then decide to do, like we said, user space processing for the data that you collect. And we have this advice category of gadgets, which allows you to generate network policies for a specific pod. So that I think can be really handy for such cases. But if you have, again, a specific need, we can see or to see if there needs to be a custom gadget, or you can do that. But the idea is that you can head to our websites, look for the advice category, and give it a try if that kind of generates the network policies how you like.
And thanks, Qasim. I have this question for up to now. You can actually can.
Okay, I think now for the use case, I think Maya can take over.
Sure. We wanted to share sort of a real life use case of partners that are using Inspector Gadget today. One is the open source project Cubescape. It's also a CNCF project by the folks at Armo. And basically what they are focused on is security in Kubernetes, and they're really taking vulnerability scanning to the next level. So, typically what they're doing is typically you have these vulnerability scanners that overlay information from the CVE database, and the result is typically a long list of vulnerabilities. And what Cubescape is doing is they wanted to enrich these basic scanners with data from runtime by installing this node agent to the cluster. And part of that node agent includes our trace open gadget, which is really cool because it gives information about when files are open open by the system when particular workloads are running on the cluster, so you can really understand like what is going on under the hood as it relates to files being opened and if there's potential for vulnerabilities in that act. And with the Trace Open gadget, the Kubescape project uses a lot of valuable information that Inspektor Gadget surfaces up. It gives you the file name, the file path, along with some other fields, and the Kubescape team is able to use the Trace Open gadget in their scanner to identify which files are touched by the container during runtime and when workloads are running. So this takes their like a sort of basic vulnerability scanner to the next level. And the Kubescape team did a sort of joint webinar with the Inspektor Gadget team to dive into this a little deeper. So on the CNCF like on-demand webinars, you can find that and learn a little bit more about their use case. But we love like partnering with different projects and folks to really make sure everyone's aware of the power of Inspektor Gadget and how it can enhance their projects. And it was cool to partner with the Kubescape team on their vulnerability scanner. And I'll hand it to Kazim to dig into some more gadgets.
Yeah, thank you so much, Maya. I think that's Kubescape is a great example of how a security platform kind of uses Inspektor Gadget. So now let's try to talk about some general cases. I think we already had this question about where Inspektor Gadget can help. And this is one of the scenarios in which you have a high network traffic and you don't know which pod is doing the excessive network traffic, and you want to be able to identify that. And for that, we have this top TCP gadget. What it does actually is collects the data about all the network traffic and being able to sort them in an order in which you can identify if a specific pod is the reason why you see excessive network traffic. So in order to showcase that, I have a slide demo. So let's try to identify a pod with the most IO activity. And to do that, similarly, like again, I will do a kubectl gadget run. Name for the top TCP gadget, I'll search it across the entire cluster, which means I'll select all the namespaces. And then there are some other flags for fine tuning. And then I'll sort by the amount of data sent by a pod. And we keep it running for a bit since I set a specific interval. And you can see here, it gives you the overview of what is happening across the cluster. This connectivity is kind of the tunnel between the customer cluster and the control plane. And we kind of expect that there's nothing much running in my cluster, and that's kind of the one is sending the most data from the customer cluster to like the API server. And that's kind of the send bytes are actually. And if you have an anomaly there, some pod is making too much requests, that's kind of helps you to identify the top pod making the most network traffic. Let's try to head to a different use case, similar to the first one. What we want to do is we have like an application that's running that's want to do some data processing, and the processes that it spin up, the child processes are getting killed unexpectedly, and there is no way you can monitor that or observe that. So in that case, the trace kill gadget comes in. It allows you to monitor the kill event at the process level. So normally you have these Kubernetes events that also tell you if a kill is happening, but they work at a pod level. But if the child process in a pod is dying, there is no way to identify that. They did change that with C group version 2 support, but if the container runtime you're using doesn't support it, or perhaps they're discussing about bringing back the old way in which a child process, if it dies, the whole container shouldn't restart. So in those cases, like you can really run the trace omkill gadget and being able to see if you have some processes dying unexpectedly, you are able to kind of identify them. Again, to showcase that, what we will do is that we will try to simulate the scenario I mentioned. So before we do that, let's try to create a workload that we can kind of kill a process in it. So we set up a namespace. Then we create a deployment, which will be running a sleep process. We set a memory limit to it so that we could kill it. And then we'll make sure that the changes are rolled out. And at this point, you already have a pod with the specific memory limits, and then we'll start the kill gadget, and that will be looking for whenever there is a kill happening at a process level. So we try to kind of kill a process called tail. We'll start it and kill it in the and wait till the kernel killer kills it. And now since it kills it, you can see that Inspektor Gadget saw the kill and caught it, and then it says, oh, a tail process was killed. And not only that, you know the name for the process, you also have all the information about the Kubernetes and other important metadata. At this point, I want to just quickly showcase how if the Kubernetes was able to tell us something. So if I check the pod state, it was never restarted. So Kubernetes doesn't think anything happened. We will also quickly check the Kubernetes events. If there is any events for kill, there isn't. And also I'll check the last state of the pod. Because normally these are the ways you can check if the kill happened. Again, this was done on version 1.27. From 1.28, there's a support for cgroup v2. So in that case, the entire pod is killed if one of the process died, but there might be a way to disable that in future. So still this gadget doing it at a process level can be super helpful. Finally, I think the third use case I want to talk about is when you have like a excessive block IO activity happening on a specific node, and you want to be able to visualize the latency to be able to identify that. And for that, we have this gadget called profile block IO. And on the right side, you can see that I have a CLI output for that gadget. I am running it against a specific node, and then it gives me the latency distribution for the block IO. I would again demo it, but this time we will try to do an end-to-end demo in which we will actually profile a node and then actually put those into Prometheus and then visualize it using Grafana. So that's kind of what is really cool about it, that you can really export the data that you generate from Inspektor Gadget and put that in Prometheus and then visualize it as you like it. And also for this demo, we're using the IG, which is more like the Linux host CLI. So in this case, when I start the IG daemon, we need to pass it the hotel matrix listen flag so that the matrices are being exported. To kind of confirm that, we'll just hit the URL for the matrix endpoint, and you can see that it is exposing the matrices ready to be scraped by Prometheus. Now that we have started the daemon, we go to a client side, which could be any client. And at this point, we will start our Grafana and Prometheus stack there to be able to kind of collect that data and visualize it. So we use Docker Compose for that. In this case, again, we will access the Grafana that's running on my client side. And again, we will quickly confirm that the Grafana has the Prometheus data source configured. and it indeed has that. That means that the Grafana is able to collect all the information from the Prometheus, and then we are able to visualize that. So now everything is in place. The next step would be to really start a gadget so that we can really profile a server. So in order to do that, we'll have to kind of dissect bit of the flags we have. And this target IP is actually what we need for the gadgetctl client to talk to the remote server. And here I'll explain a couple of flags here. So again, like before, we pass it the URL for the gadget. In this case, it's profile block.io. It's coming from an OCI registry. Then we do some annotation so that Inspector Gadget knows what to do with it. We put some name and metadata to the metric. And then we have this flag called detach. Just like when you run a Docker container and pass it a -d flag to run it in the background, it's exactly like you are able to run your gadgets in a headless mode. And then that's kind of what we try to showcase here. And now, since the gadget is running, you can see that the histogram, like there is a histogram being for the profiling of the node being exported. And then we can go ahead in Grafana and try to visualize it. Again, you can select a specific scope because of the metadata we supplied when we ran the gadget, and then we can visualize it in a way we like. Again, since it's a histogram, we'll go and quickly configure it as a histogram. And once done, you can see that we're able to kind of not only at the CLI, but also being able to export the data to Prometheus, and then from Prometheus visualize it in Grafana. So that's kind of showcases the overall. I think this is super powerful, that you being able to collect data using eBPF and then visualizing it at the Grafana. I think this is overall is a super powerful capability. So to summarize kind of all the use cases I talked about, if you have a custom use case, I think this was the question in the start, you can head to the Hello World gadget. I put the link in here. You can go to it, you can give it a try, and reach us out in case you have any questions. But that's the cool thing about it, is not that you have set of limited gadgets. You can have your own custom use case and then write a gadget you like for it. Now that we've talked a lot about the project, how to use it, and different use cases, and I think one of the things, if I was a platform engineer or an admin who wants to introduce this tool, I want to be able to control how gadgets are running, right? Because the gadgets are coming from OCI registry, and you should be able to kind of limit them. And for that, we have certain mechanism in place, and one of them is actually the allowed gadgets list, which you can specify at the deploy time, and it allows you to only run gadgets by digest, by tag, or by a specific prefix. For example, you can say you have some local registry, and you say I only want to be able to pull from a specific registry. Apart from that, we also have gadget image signing capabilities, which we'll see in a short how that helps you to control gadget runs. So in this demo, what I'll do is that we're actually going to deploy Inspector Gadget, but in this case, we'll only allow a limited set of gadgets. Okay, so you can see the output here. I'm deploying Inspector Gadget, but in the allowed gadgets, I pass it a patron, which actually is for our official gadget container registry. And I only allow a gadget with the prefix called trace underscore, which means that all the gadget which have starting a name as trace, they would run fine. So in this case, trace open would be fine. But if someone try to run anything other than that, they'll get an error. So that's how you as an admin have a control over what gadgets can run. So in this case, like I said, now if I run the snapshot process, this isn't in the pattern. So the inspector gadget will complain that, hey, this is not part of the allowed gadgets. So you are able to really control what users can run. So the second mechanism, which I think is super powerful, is the image signing capabilities. So all the images that we publish are signed by our private key, and which means that if you try to run an image that is not signed by a specific by our private key, by default it would be rejected. There's also a way for you to sign your own gadgets and kind of publish them and run them, but that's in the documentation. You can pick it, but for the purpose of this demo, I would just push image to my registry without signing it, and we'll see how Inspector Gadget rejects running that gadget. So again, I use Inspector Gadget to build the gadget and publish it. It's the trace open gadget we talked a bit about. And once it's published, I'll try to run it. And as soon as I try to run it, you'll see that the Inspector Gadget will reject it, saying that it's not really doesn't have a signature to verify. And that kind of showcases how you are, as an admin, able to, even if you deploy Inspector Gadget, being able to control different aspect to it and only open the, like for example, the toggles, so that people can really use the gadget you like. That's it for the demos. I'll give it back to Maya to tell us what's next in the project.
Yeah, just wanted to give you guys a little overview of what we're working on, trying to clean up some things for the support of the headless mode. We, of course, are always wanting to document the end-to-end use cases and make sure the documentation is up to date and super helpful to everyone who's interested in the project, whether that be using gadgets or even building gadgets. Want to make sure the documentation really conveys how to use Inspector Gadget and also includes end-to-end use cases to make it really digestible for people. We're also working on a plugin for the headlamp project, which is another CNCF open source project, which is a Kubernetes UI. So that is a area of opportunity for us to make Inspector Gadget even easier to use for those who prefer to use a UI to work with different projects. And then, of course, we're always thinking of new gadgets and looking to you all, like community members, to maybe create some gadgets as well. And then, yeah, on that same thread, like, please feel free to join us. You can find information at our website. We're on Slack in the Kubernetes Slack as Inspector Gadget, so you can find us there. And of course, our GitHub is available to you all as well. So yeah, would love for you to reach out if you have any questions or anything like that. Our Slack is, I feel like community members are super responsive on there, GitHub, whatever it might be. So that's a little bit of the project, and really appreciate your time, and we can definitely take some questions if there are any, or have a little chat about the project.
Awesome. Thank you very much. And in the chat, Oscar is saying, greeting from Guatemala. And he says a very interesting, really interesting project. So head off to, it's a wonderful presentation you both guys gave. And thank you, Kasim, for the wonderful demos as well. So I kind of try to recap because there's so much going on right now in the Inspector Gadget. So I like to see it as a framework, because we have separate technologies to do their job. So currently, you can still use Grafana and Prometheus for your observability and visualization need. What Gadget does you, if I let's say hit a command kubectl get node, kubectl top node, I don't have so much information into it. Sometimes it misses all of the information I really care about to see. I can build a gadget and deploy into the Kubernetes in the Inspector Gadget. And then what end up happening, it enhances my CLI. So I can see in the CLI what's going to happen. And you actually filter out a wonderful CLI. It's telling you the top layer, what top layer it is. So it's a developer experience is in place. Then after, if we deploy all the gadget ourselves, I want to feed this data. I don't want to see it in the CLI. I want to see it in a Prometheus and Grafana dashboard. So I can actually give an endpoint as a user, and then I go into the Grafana dashboard, you collect the metrics from the Prometheus, and you can see it. So it has two needs. You can enhance it to CLI and also on the observability layer as well. So without a further go, is it a good recap of all we have seen spoke about?
Definitely. I thought that was a great overview, and just like, yeah, a reminder, you can use our gadgets that are off the shelf as well. Like all the ones that Kasim demoed are available to you all, and you can plug it into whatever tools you'd like, visualization tools, whatever it might be.
Yes, and I think Qasim also during this demo also showcased like I want to build a new gadget. So he tells us there is an artifact hybrid. So you are using OCI registry, meaning that you pull the images on the OCI registry. I can pull it from the OCI, run it my cluster, and start using it. But the one question I'd like to ask for the Qasim is there a new CRDs in the Kubernetes cluster? Because gadget is not a kubectl command. So is there new CRD you actually embedded in the Kubernetes cluster and then starting to enhance the existing functionality of the Kubernetes? So how many CRDs there? Or is it anytime a new gadget is in place, I need to rewire the programming language to run a controller in the Kubernetes and then actually start using the gadget? So is there anything new extension in the Kubernetes you guys are actually pushing?
No, I think one of the things we mentioned about this headless support is actually we're not really doing anything with the CRDs upstream, but we want to have our own. So which will allow you to right now, for example, when I was running the gadgets, I was running them using CLI, but at some point we want to have our own CRs where you can just use kubectl apply them, and that will trigger the gadget runs. So that's something we will eventually do, but there's nothing upstream that we are kind of contributing.
Awesome, great. So before I let you go, final question, Maya, tell us where do actually the project is actually thriving now in the ecosystem, where it's actually what it should be the roadmap in the near future. So the final question, how the people, if they are going into the KubeCon Salt Lake, is there are some ways guys people can meet you and talk to about your project and want to hear some stories? So any participation in the Salt Lake?
Yeah, we'll have a project booth at the project pavilion where they have all of the different CNCF projects. You can find Inspector Gadget there. We'll be like represented at the CNCF, the pre-day, the pre-KubeCon day, and the Cilium and eBPF day. I'll be on a panel, and we'll have some other folks talking about Inspector Gadget. One of our teammates has a lightning talk, so we're all over the place, but would love to, and Contribute Fest. I should definitely mention that we're gonna have, if you want to get some like hands-on experience with the maintainers at KubeCon, if you're going to be in Salt Lake City, please like come to our Contribute Fest session, and the maintainers will be there. We'll like have our laptops and actually be working with the project, which will be really fun. So that one is like a great way to get some hands-on experience. So yeah, we'll be there in all sorts of different capacities, and come to the project booth and say hi. That would be awesome.
Awesome. Thank you very much. And I will include the link. So I think people who actually showcase some of the demos shown by both of you guys, they definitely want to see it, because I want to extend the CLI of the Kubernetes, because it sometimes doesn't tell me anything. So I need to extend the functionality. So it tells me, pinpoint me, where should I go and fix the problem. In order to do that, I need more data. And this project is going to be a very healthy need for every administrator or the developers who are working on Kubernetes on the daily basis. So without I will leave you, is anything else you want to share with the audience? No. Okay, so once again, thank you very much. This is our 50th webinar on the Cloud Native Islamabad YouTube channel. Hope the guys who actually joined the channel liked it. And if you have any question, go into the Kubernetes Slack and search for Inspector Gadget YouTube channel in the Slack channel and talk to them as well. So I kind of recap once again, as organization continues to adopt Kubernetes and cloud native technologies, managing complexities of managing dynamic environment increases, and Inspector Gadget is a powerful solution for combining eBPF system level observability with Kubernetes native workflow. And it is a go-to tool for you to improve in performance, strengthen security, or gain better visibility in your infrastructure. And if the demos you showed that stand out, tells you this as a standout tool to enhance the Kubernetes on the CLI and scrape the data for the Prometheus, so can actually more visibility into the layer. So once again, I really enjoy everything you discussed on this show and look forward to actually seeing how this project is evolved. Once again, big thanks for you for your participation in the YouTube channel. Have a wonderful day, everyone. Stay healthy, stay bye-bye. We will meet you soon in the next webinar. Bye-bye.
Bye. Thank you
Bye,
so
thank
much.
you.